Assalamu alaikum wa rahmatullahi wa barakatuh. Today I am here before you to present our work that is titled as a novel large language model based approach for automated Seerah and Hadith mapping that is connecting Islamic historical narratives through vector search and semantic analysis. I am Mushfiqur Talha and other authors are brother Mohammad Galib, brother Nabil Mosharraf and brother Dr. Riasat Islam. Now, let's introduce yourselves to the terminologies that we will be using. So at first, the Seerah is the biography of Hazrat Muhammad sallallahu alaihi wasallam that are mentioned in chronological order. And the Hadith are the sayings, actions, approvals, and advices of our Prophet Muhammad sallallahu alaihi wasallam that are narrated by our forefathers such as Sahabi, Tabi'i, Tabi'in, etc. Linking of the Hadith and Seerah poses some challenges that include large volume of Hadith and Seerah, and we need to handle this information carefully. So we need an automated process that can find relationships between the Islamic texts and make these tasks easier for us. So our objective is to use machine learning techniques like vector search and large language models that can automate this process. So let's dive into our methodology that we have followed throughout this process. At first, we extracted the texts from the database and removed unnecessary words, punctuations, and symbols. This could harm the natural language processing and query. Then we split the Seerah events into several paragraphs, and we tried to maintain the context of these paragraphs of these events. Now, in the tokenization part, we tokenized and created embeddings of all the texts, and we stored the Hadith embeddings in the hierarchical navigable small word data structure. This data structure uses the trade-off between accuracy and speed, and we mainly used this data structure because of faster nearest neighbor search. Then we saved the Hadith embedding indices, and for each of the embedding of Seerah paragraph, we then carried out the query on Hadith indices and saved all the related Hadith IDs for each of the paragraphs. And the process is mentioned here as the flowchart. So after this process, we found out a total of 1660 Seerah paragraphs, and for each of the paragraphs, 10 related hadiths were found. That makes a total of 16,600 Seerah paragraph and hadith pairs. Then for each of these pairs, we have carried out a chain of prompts for finding out the match type. Now here is the flowchart of our prompting procedure. In our flowchart, we have carried out 3 prompts, and I categorized all of the outputs as these 5 categories that is given here. So the completes are the above 2 categories, and the partials are marked differently because they need to be manually validated, that there may exist some pair that may be considered as complete. This task was the most challenging part throughout our work because we have previously shown you that we have a large number of pairs in front of us, that is 16,600 pairs. This is manually validating this is very hectic task. So we took a sample of only 100 Seerah paragraphs and carried out the prompts on these 1,000 pairs. Among the outputs, we found out that the number of complete matches is 100, which could be manually checked, and we manually checked them and updated the test set along with it. But the number of other matches were very high. Totally 600 no matches were found. So we took a sample of 100 no matches from them and checked them manually and found out that all of them were correct no. That is the LLM responded correctly to the no match types. Later on, we added 50 more Seerah paragraphs to check that whether the process is not biased toward these 100 Seerah paragraphs. Accuracy calculation metric finding is also a bit of challenging, was a bit of challenging task because we couldn't find the accuracy for all of the match types. We only considered with the complete matches, since we could verify all the complete matches but not the other matches. So we defined the anomaly of these complete matches, such as those that shouldn't be complete, but the LLM gives output as the complete match. So we carried out two experiments and the results are below. In experiment 1 and 2, we found completes of 119 and 121 respectively. Among these completes, 5 pairs and 6 pairs were mistaken. That shouldn't be complete by the LLM, but the LLM gives complete. And we finally found out that our average accuracy is about 95%. And when we run our process finally, this is the final output of all of the match types. The remaining match types that is not mentioned here are marked as no. So we totally found 1,814 pairs among the 16,600 pairs as complete match, and others are the partials. High priority partials are marked because they need to be manually validated later on. In our process, we have limitations of the embedding models, because the model that we used here, it is ranked as 42nd in the massive text embedding benchmark leaderboard. And the HNSW data structure that we used creates trade-off between accuracy and speed. So to obtain the speed, we traded off the accuracy a bit. And the prompting in our scenario also has a room for improvement. Finally, before drawing our conclusion, I want to say that our work has provided an automatic system for relating hadith to Seerah that can be further improved. And in our future work, we have figured out some points. That is, we can address the embedding model limitation and the LLM limitation, which can be improved. And the accuracy metric that we have used here, it is not complete reflection of the total work. So there is a room for good improvement in this metric calculation, and manual validation process is also needed. And obviously, we have much more room for improvement in the prompts that we have used. So I want to conclude here. Jazakumullahu khair for being patient. Assalamu alaikum wa rahmatullahi wa barakatuh.